Welcome to the class of ORF prediction and translation of a gene sequence. ORF means open reading frame, and translation here means conversion of gene sequence into a protein sequence. These two tools requires a gene sequence as an input. So to provide input for these two tools, we have to collect a gene from GenBank or DDBJ or EMBL. In this class, we are going to collect a gene from NCBA. So for that, we have to go to the Google and then we will type NCBA, and then within the NCBA we will go to the nucleotide because it's going to have a gene sequence, and then you type any name of a gene and then you type and enter, and it will give a list of genes. In this list of genes, you can select any one of the gene in FASTA format. So now we get the gene sequence in FASTA. So now, in order to carry out ORF, we will go to the tool known as ORF Finder, which is in NCBA. Okay, so you type ORF Finder, it will give a list. In this first, you can see ORF Finder in the NCBA. Then once you reach the ORF Finder, you can see that the sequence should be submitted in FASTA format. So we collect this gene sequence by selecting the sequence and copying it, and then we just paste in this box. And then if you want to select a codon for a particular ORF prediction, if your organism is present within this list, you can select the organism. If you are unaware about this codon sequences about the gene, then you just keep this as a standard one. Then after pasting the sequence, you can click this ORF, and if you know the access number of a gene, you directly give the access number and you can carry out the ORF find option. If you are not knowing that, you should click the ORF find too. Then the ORF means, I already told you, it's nothing but open reading frame, which means that in a gene sequence, how many ORFs are present. ORF means it is actually identified by using the start and stop codon. So the sequence which is present between start and stop codon is considered as one ORF. So now if you submit a sequence, it will find out how many this ORF are present in this particular sequence, and then we are getting the results in 6 frames. Now we are going to see the result of this ORF finding tool. And now this is the graphical display of the ORF. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ORFs are identified in this particular submitted gene sequence, and the ORF sequences are listed on the basis of their length. You can see this, there are about here +3 is the one frame, and +1 is one frame, -1 frame is one, -3 is another frame, like this. +1, +2, +3, that is 3 frame, forward frame, and -1, -2, -3, they are the reverse frame. So we are going to have predictions about 6 frames in our gene sequence. We are going to have prediction about 6 sequence, and here the largest length sequence. So if we select this, it is actually highlight, which is the ORF we are selecting here. So this is the ORF we are selecting, and here you can get the amino acid sequence of this particular sequence are also given here. So this is how we can identify the frame in which we are going to have the largest ORF. So you can see, as the sequence clearly indicates, that we are going to have a largest ORF in the 3rd forward frame, and then the length of that sequence will be 1458, and the number of amino acid what we are going to get from this ORF is 485, and then the amino acids are given in the second line. So this is the line which indicates the amino acid sequence we are getting from this ORF prediction tool. So once you convinced with the ORF, you can click the button accept, and then now you will get the ORF is changed like this. Okay. So if you want to get the amino acid sequence, you can click that and you will see the sequence, and you can save this page as your wish. And you can also run BLAST program from this locations. If you want to get similarity study purpose, you can use this option. Otherwise, we can't use this. So this is how we can predict the ORF by using this ORF predictor, which is available in NCBA database. So as this tool says, there are about 10 ORF is there, and then the largest ORF in the +3. Okay. Okay, now the second half we are going to see about the translation of the gene sequence. So for that we are going to the Google, and then we will choose the tool which is known as XPASI Translate tool. We are going to use XPASI Translate tool for the translation. And once you go to this particular tool, again you can see it requires either a DNA or a RNA sequence. So we simply paste the sequence, and we have to need only the sequence, so we remove the FASTA file formatting part of this file. And then you can see here again a genetic code is present. So if you know the organisms, and you can select a genetic code, otherwise you keep this as a standard one. And similarly here there is an option how the start and stop codon should be represented. So the default places start codon will be represented by using net, and stop codon will be indicated by the word stop. Okay, now you click this translate sequence button, and now we are getting 6 frames of translation. Like this is the 5-2 frame 1, and this is frame 2, and this is frame 3, and this is frame reverse frame 3-2 frame 1, 3-2 frame 2, and this. So in ORF Finder, this is actually given as +1, +2, +3, and this is -1, -2, -3. So now here we are seeing the different terminologies. Now by seeing this frames, you can clearly indicate here you will have only possibility of this much peptide in the case of frame 2, and this case of frame 3 also we will get a protein sequence from methionine to stop smaller one. But when you go to this frame, you will see this. When you start a protein sequence here, then it will goes on and on up to this, you will get a single polypeptide. So similarly if you check the other frames also, this found to be the major one. So as you remember before, even ORF printer has also predicted that we will get the maximum length in the +3, that is third frame, forward frame. Here also we are getting it. So once you confirm this is the best frame, then you have to click the frame, and then the only frame how it is represented, and you can see here the frames is indicated by the red color. And then to get a protein sequence, you have to select one of the methionine which is highlighted here, or the highlighted residue here. So as we all know that gene sequence will start with methionine, so we will select one of the methionine. If I select this methionine, the peptide stops here, but we need a larger sequence, so we have to select this methionine so that we will get this much size of molecular chain. If I select this methionine, I will get this much. Okay, so I am going to select this methionine, and now the sequence is available in a Swiss prot format. And like ORF Finder, we can also do BLAST here. We can also search the protein sequence by using ScanForSight tool, and we can analyze primary structures by using these tools, and we can submit our sequence to 3-dimensional structures to Swiss model. So these are the additional options are available in the case of XPASI tool, and we can also convert this translated tool by using this FASTA format tool, so that we can use it for any other purpose. So we can save this file by using so we create a new folder, like you can save this as class, and in this folder we will say this translation, XPASI translate tool. Along will be there. You can remove the other part. We will save this as XPASI translate. So in future we can use the sequence. Similarly, this page is also saved in the same folder as ORF file. And then we can also save this FASTA sequence also for the future purpose. Okay. So this is how you can save the files after we carried out the translation. Okay. With this we conclude the part of ORF Finder and XPASI translation tool. Thank you.